How you doing, Year 10s? Welcome to another episode. This is still our What Are the Types of Chemical Reactions series, and this time we're into metal displacement. Let's do it. Okay, what are the types of chemical reactions? And we look at metal displacement in this video. The understandings and outcomes, you need to be able to identify a metal displacement reaction. You need to be able to list the most reactive to least reactive from an activity series, and then you also need to use some data to construct an activity series. So what is a metal displacement reaction? A metal displacement reaction is where the position of the metals swap places. By that, we mean one will be a solution of metal ions and one will be a solid. And what will happen is in this redox reaction, where electrons are transferred from one to the other, one will come out of the solution and become a solid, while the other metal goes into the solution and becomes an ion. So they essentially just swap places. Metal displacement. The solid goes into the solution and the ions in the solution form a solid. Metal displacement reactions are simple redox reactions because they do involve that transfer of electrons, and the direction of electron transfer is from the more reactive metal to the less reactive metal ions. More reactive metal undergoes oxidation, less reactive metal undergoes reduction. So a simple experiment that we will do in class is where we grab a zinc strip, which is a nice shiny metal, and we place it in a solution of copper 2 sulfate, which is a nice bright blue solution. What we find is when we put the zinc into the copper solution, we immediately see some dulling of the zinc metal. What's happening there is the copper ions are forming copper solid on the outside of the zinc metal. The zinc is a lot more reactive than the copper ions, so those copper ions will gain an electron from the zinc to form copper solid, and it starts to coat the outside. What's happening to the zinc though? Well, it's displacing those copper ions that have formed a solid. So the zinc metal is turning into the zinc solution, while the copper ions in the solution are turning into copper solid. So what we physically see is the brightness of the solution, the blue, starts to decrease and becomes more colourless. That's because the copper ions have turned into copper solid. We would also see the zinc metal being eaten away, which means that the copper ions have reacted with the zinc metal, and we say that that starts to corrode. The copper, you might think of it as being that nice kind of colour, but in the solution it's actually kind of like a black. If we pull the zinc out of the solution, you'll see that it does have that copper colour, but it does take a little bit of time. So the things that we can observe: the zinc begins to dissolve, the copper is formed on the surface of the zinc, and then the solution becomes colourless or less blue. So what's the chemical reaction or the chemical equation for this process? Well, we have zinc solid, it's a metal, it's a solid, plus a copper sulfate solution, CuSO4 aqueous. And we're forming copper solid, plus we'll form zinc sulfate. So the zinc has gone from zinc solid to zinc ions, the copper ions have gone from copper ions to copper solid. Metal displacement, they've just swapped places. Okay, now we need to look at what's called a reactivity series. A metal displacement reaction can only occur when a more reactive metal is placed into a solution containing less reactive metal ions. The more reactive metal will undergo oxidation and lose electrons, and the less reactive metal will undergo reduction and gain electrons from the more reactive metal. Now we can build up a series with all the metals listed in order from least reactive to most reactive, and that's called an activity series. In our activity series, we have the metals on the left and we have their ions on the right. So we can see in this activity series, potassium, K, is a very reactive metal, so it's right at the top. Au, which is gold, is right down the bottom, very unreactive metal. And then we have all the metals in between. If we have a look at our example from before, we had a zinc strip, so a zinc solid, and we placed that in a copper 2+ solution. So we can see that those were our two reactants on the last slide. Now there was a reaction between those two things. So zinc solid formed zinc ions and copper 2+ ions formed copper solid. So here we have this back the front Z, and that is evidence of a reaction. We have a metal that is reactive, which is placed into a less reactive metal ion solution, and our equation or our reaction occurs. Let's have a look at this example. We have iron nail, Fe, and we place that in a solution of copper 2+. So here we have iron, which is more reactive than copper. So we have our iron nail, we've placed it into a less reactive metal ions, the copper 2+. We look like we'll be able to form this negative gradient. So the copper 2+ ions, they're less reactive than the iron ions. So what we will see here is there will be a reaction. Iron will form iron 2+, and copper 2+ will form copper solid. So a metal displacement reaction will occur. The equation would be Fe solid plus Cu2+ aqueous goes to Cu solid plus Fe2+. Metal displacement, the metals have swapped positions. The final example, a piece of silver, Ag, is placed into a solution of magnesium nitrate. Now, magnesium nitrate contains Mg2+ ions, so that's what we're looking for in this series. So here we have our silver right down the bottom, very unreactive metal, and then we have our magnesium ions, which are right up the top of the table. So they are quite reactive. But the problem is silver is a very unreactive metal, and when we place that in a solution of a more reactive metal, nothing will happen. The silver does not want to release its electrons, so it's holding onto them too tightly because it's unreactive. So no reaction will occur here. Okay, the final thing we need to do in this video is to construct an activity series from some experimental data. Now, a chemist carried out reactions with three metals, X, Y, and Z, and solutions of their metal ions, X+, Y2+, and Z+. They made some observations below. Metal Z dissolved in Y2+ solution to form a deposit of metal Y. Metal X did not react with Z, and metal Y did not react with X. Using this information, place the three metals in order of increasing reactivity. So for this type of question, you need to look at each individual part separately, and then we'll come together at the end to work out the answer. So in the first dot point, it says that metal Z did react with Y2+ to form a deposit of Y. So I can write the little equation, Z plus Y2+ goes to Y, which means that Z must be a reactive metal because it's reacting with the metal ions. So Z and Z2+ must be above Y and Y2+ in the series. For the next dot point, X plus Z+ had no reaction. So what does that mean? Well, that means that X must be somewhere between those two. It's going to be, it's less reactive because it didn't react with Z+, so it must be below it, but we don't know where it is, so that's why I've put those two crosses in there. Finally, if we get metal Y and put it in a solution of X+ ions, we also see no reaction. So that tells us that X is the most is between Y and Y2 plus, because Y must be the least reactive metal. It's the one that does not react with anything else. The Z, it could react with everything, and the X, well, it could only react with certain parts of Y. So that's a little bit of a tricky one. We might need to go over one of those in class, but essentially we're using the series to work out an order of increasing reactivity. Thanks for watching, guys. Don't forget, drop a like on the video, subscribe if you're new, and I'll see you next time.